Hi, good evening, everyone, students and parents. Now, today we are here for part two of conquering the PSLE Science structured questions. Okay, I hope all of you have your materials with you. All right, when you register, you have the link. Right, if you have not printed it, you can go and look at the email and click on the link. But I'm just going to send everyone the link here for those who don't have the copy. This. All right. So if you don't have the materials, I have put it in the chat, right? And you can access the soft copy. Okay. All right. Now, so great to see everyone back here. All right. Last lesson, what did we went through? Last lesson, we went through the answering framework, question analysis framework. Okay. We also went through a few experiment-based question, the answer template for some of the experiment-based concepts. Okay. Like for example, aim, we went through the variables, the aim, okay? So those are the very start, hypothesis. That's what we went through. Okay? So today, if you look at today's material, today we'll be covering relationship, we'll be covering fair test and conclusion. Okay, but that is not all. Okay, we are still not at the end yet. Remember, next week there is still one more session. Okay, so please also attend the session next week so that you have a complete set. Yes, hi Chloe. Hello. I hope you had your dinner. This week I did not eat McDonald's. Not to worry. Okay, so without further ado, let us begin. Right, so let me share my screen. Right, so like last week, okay, just to let you know that okay, there's only myself teaching, okay, and I'll be answering your questions if I see them in the Q&A or in the chat. But as much as possible, be patient with me, and you must understand that I'm the only one who can answer all your science questions, so I won't be able to answer to all of you. Okay, I try, and whichever I see, I try to answer. Okay, all right. So let me share my screen. Okay, so today is part two. These are the things that we'll go through, as I mentioned. Relationship, fair test, conclusion. Okay, so if let's say you still have trouble with variables, with aim, with hypothesis, okay, we have covered those last week, and you can review those in the YouTube. Okay, if you do not know the link, just go to YouTube, search My Stretcher, and then you find the channel. You should be able to find the part one video there. Okay, all right. Let's see. Okay, control setup, we'll talk about it next week. That will be the last one for the experiment-based question. But the control setup, just to put it here first, since you asked. The control setup is used to compare with the experimental setup, right? To confirm that whatever changes in the measured variable is only due to that one change variable. Okay, so that is the purpose of the control setup. All right. We'll cover that in greater detail next week. Thank you for asking. Okay, right. So today we'll focus on these three. Control setup will be next week. And then next week we'll also cover some of the answer templates. Okay. For other topics. For topics. Okay, these are for experiment-based questions which can be across any topic. Okay, because they are more general, they are like skill-based, okay, instead of topical concepts. Okay. All right. Is it done? What's the independent variable? Independent variable is a change variable, okay? Okay, that is the change variable. Independent variable is change variable. But in PSLE, most of the time we use change variable, okay? This is also the same as independent variable. All right. But that is seldom seen. But some teachers use independent variable and dependent variable. So dependent variable will be the measured variable. So it's good to know both, but what is required for PSLE is just changed and measured. Okay? But some teachers will use dependent and independent. A dependent variable cannot always be directly measured, right? It can. It can. Okay, Gabriel, it can. Like for example, okay, let's look at this relationship, right? So if you relationship, I think all of you will have seen relationship kind of questions if you have done your practice. And all of them can be in the form, you can always determine a relationship based on the data given, which are in the form of table or graph. Okay, let's look at this example. Now, this is a light question. That's based on this without the experiment setup. We have the number of sheets of material P and the amount of light that could pass through the sheets. So this is very obvious that, okay, we are changing the number of sheets, 1, 2, 3, 4, 5. So this is the change variable, which I just write as CV. And what we measure will be the amount of light that passed through. Okay, so one of you are asking if I can measure this directly. So I can measure this directly. But you also mentioned rate of evaporation. So there are cases whereby you can measure directly. You get a value straight from your what you measure or what you record. But there are some where you have to determine. Like for example, rate of evaporation. Very good. Gabriel, your question is very good. So if you are trying to determine what's the rate of evaporation, then what could be your measured variable, Gabriel? Measured variable will be what you measure during the experiment. Okay, so if you are trying to find out the rate of evaporation, then your measured variable could be, yes, the amount of water left maybe after a certain period of time. Okay, there must be a time frame, right? Okay, so amount of water left after maybe 1 hour. Then you compare between setups, that will tell you which one evaporated faster. So rate is not something that you can determine directly. You have to measure something else, then from there, tell what is the rate of evaporation. Okay, so there are some which you can measure directly, like what is in this page here, but there are some which you need to determine, like rate of photosynthesis, rate of evaporation, basically anything that is rate. That one you cannot get straight from the experiment results. Okay? Right, so coming back to this, thanks for asking those questions, actually very important questions. Right, because they can actually ask you like, in order to determine the rate of evaporation, what should Gary measure in his experiment, for example? Okay, it is a very likely question. Okay, I'm not saying that it's going to be coming out, but yes, you all need to know that some are measured directly, some you need to determine like rate of evaporation. Okay. What's the difference between question that ask? I'm not too sure what you're asking in Kairos. Okay, let's continue. All right. So in this diagram, in this graph here, you can see, right, we have the table and then it has been placed into the graph. So they're just showing you that there are different ways to express your data. Okay, to record your results. Put it in a table, put it in the graph, and you must be able to read both and be able to identify which are the changed and measured variables. Okay, so likewise, now usually for graphs, the x-axis, which is the horizontal line, okay, this is the change variable, and the amount of light is the measured variable. Okay, so usually the horizontal one, which is what we call the x-axis, this is the x-axis. Okay, it is the change variable. And usually the vertical one is the measured variable. This is the y-axis. Okay, so all of you must know this. All right. What's the difference between question that ask, affect, and relationship? Kairos, if I understand you correctly, if a question asks you how a certain variable affect another variable, that is a relationship question. So they're telling you that the way they phrase it when they say of one variable affect the other, and you're trying to find how they affect each other, that is a relationship question, which is what I'm going through today. Okay, this part here. Ah, so you must be able to tell that that is a relationship question. Okay, so I'm just showing you. Okay, yeah. So that is this part here, Kairos. This first thing. Okay, this first thing. How a change variable affect the measured variable. So the question can be phrased in different ways. Very seldom they will ask you, what's the relationship between variable X and variable Y? That one is too straightforward. Okay, in PSLE, the more common question type would be, okay, for relationship, right? The more common question type will be what? The way they phrase it, it will be describe how variable X, okay, affects variable Y. For example, this is just one example, right? So the simplest way to write it. So it usually starts with describe how, and then there's a word affects or is affected by. It's just change the order. Okay? So this is how they could phrase it in PSLE. Alright, so that's for writing for relationship in the structured questions. Okay, so you must be able to spot that is relationship. Okay, if you're not here for the last lesson, you can watch the recording online on YouTube. Okay? When would the x-axis not be the change variable? Now, what I say here, like I said, very commonly, x-axis is the change variable. Y-axis is the measured variable. But you must always read your question to be very sure. Alright, because the question will give you information, right? Like what they are going to change and what they record or measure. Okay? But usually this is a scientific convention basically, but sometimes they don't follow the convention so strictly. Okay, but I would say most of the time would be like this. All right. Okay, let's move on. Right. So when you are dealing with relationship question, this is how you phrase it. There are really different, there are quite a number of different ways to phrase your answer. But we are just giving you two of them so that you can follow if you are not sure how to phrase it in your own words. Okay. So all these templates will be very helpful. All right. So if let's say, okay, since we were talking about real evaporation just now, so uh, as the temperature, I'm just giving an example, as the temperature of surroundings increases, the rate of evaporation increases. That can be how I write it. Or the volume of water left after 1 hour decreases. Okay, so depends on whether you want to write the science concept or what is measured in the experiment. Both are fine. Okay, all right. So this is when you use as the something, then the something increase or decrease. But I can also phrase it in another way. The greater the or smaller, in this case, temperature, right? So temperature will be higher. The higher the temperature, the faster the rate of evaporation. Okay, so you are using different terms, but what is important here, if you are using this version, then you should be using comparative terms, right? Because the greater, the smaller, the higher, the lower, the faster, the slower, all these are comparative terms that you must have in your answers. Okay, so comparative terms very important. Okay. Yes. All right. Okay, let me just look at what is change variable? Change variable is the variable changed intentionally for your experiment. Okay. Which of them is more suggested to write in PSLE? Actually, anyone, either one. Or you can come up with your own version as long as you get the trend correct. Okay, so both these two are the suggested one. Okay, so up to you to choose. Whichever you feel you are more comfortable with and you feel it's easier to write. So just write what is naturally in your head. Okay, no need to overthink. Just choose one. Okay, if you want to go with the first one, just go with the first one all the time. All right. Can I say that when the CV increase, the MV decrease? I think that's okay, Elena. So one of you is saying that instead of as, you use when. When the change variable increase, yeah, I think that's fine. That's totally fine. Yeah. So as or when also can. You add a two, Chloe, you add a two or not, I don't think it matters. But if add a two means that both increase or both decrease lah. Okay, so yeah, but it's not necessary lah, Chloe. Yeah, you can see temperature decreases. Depending on what you're trying to say. Let me see. What's the trend? A trend is okay. What is the trend? One of you asking. So I move on already. So if you see this kind, all right, as the number of sheets of material P increase, all right, then the amount of light decreases. That's it. That's the only one pattern. Trend is like a pattern. Okay, so how the amount of light changes when the number of sheets increase. When the number of sheets of P increases, then the amount of light that pass through decreases. That is one trend. Okay. Then there are cases whereby there are more than one trend. Okay, and this is more for those that are in P5 and P6. I understand that there are some of you who are not P5 or P6. Okay, so you are unlikely to see questions with two trends. But if you are in P5 and P6, then please already start understanding what are trends, and there are usually two. Okay, there can still be one trend tested, but a lot of times more recently like to test two trends. Okay, so two trend is when you see. You look at this graph here. First part of the graph looks like this. It goes upwards. It's upslope. Okay, sorry. Okay, let me use this method. Okay, it's upslope. First part. Then second part of the graph it is horizontal. So I have two parts to describe. From 0 to 20, this is the first part. Then from 20 to 30, this is the second part. Second trend. First trend, second trend. First trend is it was increasing. Second trend, it remains constant. Okay, so that is a trend, a pattern, how it has changed. All right. Control setup, I have mentioned it just now. Okay, we'll talk about that next week. Okay. Is it possible that if the relationship between the change variable and the measure variable is only one? Yes, you can have just one relationship, it's okay. Yeah. It's not aim, it's not the aim. Aim is what you are doing your experiment for. Okay, so if you check the templates for aim and relationship, they are not the same. Okay, when you write the aim is like, why are you doing this experiment? That is the aim. And relationship is, once you got a result, then you write down how are the variables related to one another. Okay, so Elena, I just answered your question. So this is not relationship is not the same as aim. Okay, so how do you write for two trends? So basically, if you are writing for two trends, you keep to the same template, just do it twice. Okay? If you need to write two times, if you have two trends, then you write it two times. Okay? Okay, Kaden, your science teacher told you that there will always be more than one trend in the PSLE. Okay, I will not I won't say I totally agree with your teacher. I mean, there's a high chance that there are more than one trend, but I won't say for sure 100% it's going to be two trends. Okay? Because I'm not the setter. They can choose to give you one trend. It is still within syllabus. They can give you one trend, they give you two trend. I wouldn't say it's guaranteed. Okay? It's not guaranteed. But they say it's a high chance. Okay? More often. Gabriel as like will you write it in another way, like as something decrease, something else increase? Looking at the graph from bottom to right or right to left. Yeah, I think Gabriel, if I understand you correctly, yes, you can write it the reverse. For example, like now, this part here, if let's say I talk about the first part, okay, as the amount of carbon dioxide provided increases from this to this, the amount of oxygen increases from this to this. So instead of doing it this way, I could write the reverse. Okay, meaning that I could write as the amount of carbon dioxide provided decreases from 20 to 10, then the amount of oxygen produced decreases from 8 to 0 cm cube. Yes, I think that is perfectly fine. Okay, but the trend must still be correct, no matter it's increase or decrease. Okay, so that their relationship must still be correct. All right. So like I was saying, if you have more than two trends, sorry, if you have more than one trend, right, use the same template twice. You can see that this is one trend, this is one trend. Okay, this is the first, write that again. This one, the first sentence is the first trend. Then the second sentence is the second trend. Okay? So you write it twice. You can see that the first trend, second trend, the phrasing are very similar. You just need to change the values. Now the thing about two trends is that you need to specify some values. Okay? Otherwise, the examiner will not know. Okay, because if you don't state values, right, then it becomes very vague. Like for example, if I don't write these values from where to where, then it becomes as the amount of carbon dioxide provided increases, the amount of oxygen produced increases. Then my second sentence I change. Let's say if I don't write all these values, as the amount of carbon dioxide provided increases, the amount of oxygen produced remain constant. If I have no values, then the two sentences put side by side don't make sense at all. Right? Because you are now contradicting suddenly. First question you say, oh, amount of oxygen increase. Then now, second sentence you say amount of oxygen produced remain constant. So which one is correct? So you need to state all these values from where to where, from what to what, so that it becomes very clear. And all these can be found in your graph, in your table, and you need to state all of them. Okay, if they are provided. If they are not provided at all, then of course, then that's okay. If it's not provided, you can say that as the amount of carbon dioxide provided increases, okay, the amount of oxygen produced increases, then remain constant. If there are no values provided, you can say that way. Okay, but if there are values like this, okay, then please state it clearly. Specify them. Understand? Okay, so Rusra, I've just answered your question. So state all these minutes and all clearly. Uh, Tanishka, if I pronounce your name correctly, sorry. Uh, at lower level, let's say if you are in P3 and P4, a lot of times they'll be very straightforward. What is the relationship between A and B for relationship question? But in PSLE level, just now I mentioned that at the start, maybe you join a bit later, they will usually phrase it in this way: describe how X affects Y. Okay, describe how the temperature of the surroundings affects the volume of water left behind after 1 hour, for example. So instead of clearly telling you that it's relationship question, they phrase it in this way: how these two variables affect each other. And then you must be able to tell that it's a relationship question. Okay, thank you. How to identify between trend 1 and trend 2? How to identify between trend 1 and trend 2? Now, if it's a graph, it's quite obvious. You will see that the shape of the graph changed. Or rather, you can see that the slope has changed. Initially, it was increasing. Then after that, it becomes horizontal. So that's two trends. So you state the two clearly. Okay, you split into two parts. All right. If it's only one trend, then just use one sentence. Okay, just use one sentence. All right. All right, let me move on. Okay, so let's try this question. Okay, so you look at this question. Okay, one of you ask, can PSLE ask three or more trends? Okay, unlikely to have three or more trends. Okay, it's unlikely to have three or more trends. because they are not trying to make it so difficult for you. Then you need to write a very long answer. They just they test you for two trends to test you on the skill of being able to read the graph or read the data in the table. Okay, so that's all they are testing. Your skill to identify the trend, two trends, and to phrase them in your relationship answer. Okay, but there's no need to do more than two. Okay, it's very unlikely. Again, I cannot guarantee they are not going to do it, but I would say it's very unlikely to have more than two. Okay? Okay, so some of you are already sharing your answers. Thank you. Okay, there can be a negative trend, yes. A trend is like a pattern. A clear trend is like a pattern, like how something changes. Okay, a trend is like whether it's increasing, that's one trend, then it remains constant, that's another trend, or if it's decreasing, that's another trend. Okay? Okay, then if there are two trends and they are both increasing, then yes, you have to specify a bit more clearly. But usually they try not to, they are unlikely to give you both are increasing. Okay, so it's not likely to be both increasing. Okay, so let's try to phrase this question. Okay, so you see, right, just now some of you are asking how the question will be phrased. So describe how, okay, the number of bacteria changes with temperature. Okay, so instead of affect or is affected by, okay, changes with temperature. So again, as long as you see something that phrased like this, then this is a relationship. Okay, please write this down at the side. This is how they phrase it in the PSLE most of the time. All right, so number of bacteria is what we are measuring because Jenny conduct an experiment to find out the rate of reproduction of bacteria V at different temperatures. So this is the aim. Okay, we analyze the question first. So this is the aim. Whenever you see to find out, to investigate, that is the aim. Okay, rate of evaporation, this is what they want to find out. This is a measured variable. But to determine the rate, what exactly did they measure is the number of bacteria, how the number of bacteria changes after 2 hours. Okay, so you can say this is the measured variable. At different temperatures, so this means that temperature has been intentionally changed for the experiment. Okay, so this is the change variable, 25, 30, 35, and so on. So when we write our relationship, in this case, we try to follow the template. Now, how many trends are there? So you can see, right? Okay, now let's say I look from left to right. So temperature increases, but how did the number of bacteria after 2 hours change? Okay, so you can see at first 27, 33, 52. From here to here is increase. From 52, okay, let me use another color. Maybe you can see. Okay, can. 52 to 32, this is a decrease. So you can see it is a very clear difference. One increases up to from 27 to 52, then it decreases from 52 to 32. So this is what we call two trends. If it's only one trend, it's going to increase all the way. But now it's not. Okay, it did not increase all the way. It increases, then decreases. So let's try to write out the first trend first from 27 to 52. Okay, so what you can write here as the temperature increases from hold on, as the temperature increases from what to what? 25 to 35, right? So as the temperature increases from 25 degrees Celsius to 35, how did the number of bacteria after 2 hours changed? Okay, so you continue. Number of bacteria. Number of bacteria increases from 27 to 52. Okay, this is the first trend. Right, add in the units also. So temperature, we have degrees Celsius. Bacteria, they say is the units. So 27 to 52 units. So this is the first trend. All right, this is the increase. So you see here, I highlight that keyword here, increase. But like I said, you must specify all these values. Okay, be very clear and specific when they are at least one, when they are more than one trend. Next, second trend. So again, we will start from 52. Okay, we can continue from 52 there. So that is from 35 to 45. Okay, so you can write like this. This is the second trend. Okay, so let's highlight this part here decreases, you must write, and then specify the values, the specific values. Okay, so that is the two trends. Okay, of course, you can phrase it slightly differently, right? Like I said, I'm just using the first template. If I go again, sorry, the first template as the what increase, the increase or decrease. Okay, so I'm following the first template. If you want to follow the second template, you should be saying the higher the temperature from, okay, or rather we don't use that. Uh yeah. Actually, when there are more than one trend, right, it's easier to use the first trend. Is when there are more than one trend, it's easier to use the first template because first template allows me to include the values. Right, you see, as the amount of carbon dioxide provided increases from what to what. If you use the second template, okay, you can't really include the values. Okay, so use the first one would be the best. Okay, if you need to choose between either one, okay, and you do not know which one to choose the first one. So that is the one you can include all these values easily. So as something increases from what to what, something decreases from what to what. Okay, so that's the easiest way to phrase your relationship answers. Okay, like I said, specify the values as much as you can. As long as they are provided, specify. Okay, so I see a lot of your answers did not specify the temperature or the number of bacteria. Okay, so do that. Specify them. So if you don't specify, it's not clear. Okay, so the examiner will not give you the mark. Okay, so please specify. Okay, one of you asked, is there bacteria in cooked food? I thought all bacteria are dead after cooked. There will be bacteria. Okay. There will be some amount. Yes, some of you say that definitely you cook food, most of the bacteria are killed. But I would say not all. There is a high chance that there are still some that survive, and eventually the bacteria grow again. I mean, the bacteria grow again, and your food can still spoil, right? Okay. Otherwise, how the food spoil? How did the food spoil? Hmm. Okay, Lucas, since you're asking, your answer is actually fine, but it can be better if you include the values. Okay, like I said, the number of bacteria in terms of units, just add them in to make it even better. Okay, specify them as what you definitely must put for the values is the temperature. If you don't put any values for the temperature, it's definitely wrong. Okay. But for the bacteria, I would say it's okay if you don't really write it, but I would recommend you to also state out 27 to 52, then 52 to 32. Okay? Specify those. Okay, so just cross-check your answer with mine. Like I said, and there are a lot of you, I will not be able to see all of your answers. Okay, imagine there's 100 of you and 100 of you write your answers in the chat. I will not be able to go through all 100 in a few seconds. Okay, so cross-check your answer with mine. As long as your trend is correct and you specify these values, you will be correct, okay? Surroundings as temperature. What surroundings? Surroundings. This is the temperature of the surroundings. Yeah, it's okay if you mention surroundings, temperature of surroundings. Yeah, it's okay. Okay, now I'm going to move on. Okay, now we have bacteria V that is commonly found in shellfish and can cause sickness when present in large numbers in the human body. Okay, so suggest why bacteria V will multiply very quickly in the human intestines when raw shellfish is consumed. Okay, how do I answer this question? Now, what is the command word here? The suggest. Okay, it's a suggest. Like I said last week, okay, we talked about command words, right? Suggest is when you come up with a possible reason, possible answer, possible modification to set up. Okay, so there can be more than one answer. Okay, but for such question, suggest could also mean that it's something out of the box. You must think a bit more. Okay, come up with a possible answer. So in this case, what is the hint here? The hint is that it's inside the human, in the human intestines. And what is the temperature of human? Our body temperature. You know what is our average body temperature? Around 37, right? Okay, around 37. 37.5, you need to see doctor already. Okay, it's considered fever. The clinic will say might be having fever. Okay, 37. So our body temperature around 37. And how do I link it back to the question? Okay, one of you say, so it can be any answer. No, it's not any answer. Of course, it must be related to what we're doing. Okay, the first part here. So you can see at 35 degrees Celsius, number of bacteria compared to other temperatures, number of bacteria is the highest. It increased the most from 10 to 52. Yes, increased the most. So 37, it is very, very close to 35. And you would also expect that the number of bacteria will be very high. Okay? So you must mention this 37 and compare it to our data. Otherwise, we cannot answer the question. We must compare it to what is given, 35 degrees Celsius. And that number of bacteria grow very quickly, multiply very quickly. Okay? So that you must compare it to the 35 degrees Celsius in the question. Okay, so this is my answer here. Tell me what is the human body temperature? Around 37, compared to what was given in the data, 35. And from that data, we can tell that bacteria V multiplies very quickly or the most quickly. Okay? Second part for question one. Amelia, what do you mean by second part for question one? You mean part A? Part A, I have two trends, right? So you need to put both trends. Yeah, you need both trends for that, Amelia. But one thing that I forgot to mention, right? Usually when it's two trend, you look at the number of marks. If it's 2 marks, that tells you two trends. Okay, 1 mark for one trend. Okay? So usually the mark allocated will tell you how many trends there are. So it's likely to be two trends if it's 2 marks. Okay? Shellfish is there are many type of shellfish. Oyster is one of them. Okay? Yes. Some of you asked for the body temperature is 37 degrees Celsius. Okay? Can I move on? Yeah, you can say something close to 37 degrees Celsius. You don't have to be specific as 37. You can say it's around 37, around 36 also can. You give a specific value is okay, but don't give a specific. I wouldn't say it's really specific. All right, you can say 37, 36 is okay, but it's around there. You cannot be, it's never, it shouldn't be 35. You should roughly know your body temperature 36, 37. Okay? 37 degrees Celsius, you must have the C. Okay, you must have the C. This is the symbol for degree Celsius. Degree Celsius. All right. Okay, I'm going to move on. What kind of sickness will you get if you eat raw shellfish? Now, you may not get sick for eating raw shellfish because some people eat raw oysters and all. So it really depends on how well your body can handle that and the amount of bacteria inside, whether your body is able to kill all the bacteria. Okay? If the shellfish are not clean, your body there might be too much bacteria and you might get diarrhea. If it's even worse, you might get fever. Yeah. Okay? And we don't really have to talk about the shellfish, about the bacteria. There's nothing about the shellfish, it's the bacteria in the shellfish. Okay, so our focus is the bacteria. Okay, let's move on. Now, next part here. So Jenny conducted another experiment to find out whether bacteria V can survive at high temperature. Okay, so this is what some of you are saying, right? Cook them and the number of bacteria should decrease. So this is what we see. Okay, she heated the same number of bacteria at different temperatures for 20 seconds. So these are the number of bacteria left after 20 seconds of heating. So initially it was this amount. After that, okay, it changes. So you can see, right, the higher the temperature, the lower the number of bacteria left after 20 seconds. That is another trend. Okay, as I increase the temperature here, the number of bacteria left after 20 seconds has decreased. Now, so what is part C about? So she cooked some raw shellfish in boiling water. Now, what's the temperature of boiling water? Yes, 100 degrees Celsius. Okay, so boiling water, 100 degrees Celsius, and we are then focusing on this. Okay, then the cooked shellfish was left on her kitchen table for a few hours. Okay, so explain why the cooked shellfish may not be safe for consumption anymore because she left it for a few hours. What will happen then if she left it for a few hours? Okay, but we need to relate to the results, right? So you look at the results here. What happens in this graph? Did we totally kill the bacteria? Was the bacteria 100% wiped out? It was not wiped out, right? There is still some amount. If it's wiped out, then there shouldn't be the graph here at all. It should be flat, nothing. Okay, so some of it did not die, even at 100 degrees Celsius. So this is what I was talking about, since some of you asked, right? Okay, so you need to be able to identify this, that some of the bacteria V, okay, did not die or was left. Okay, so this is the first thing that you can write. So at 100 degrees Celsius, there was still some bacteria V left. Okay, then just putting it for a few hours, then what happens to bacteria? Now, bacteria, they can reproduce very quickly. Okay, they can reproduce very quickly, especially in a few hours. That's pretty long. You put it 1 hour on the table, right? Your food already starts to spoil, depending on what type of food. Okay, so after leaving it on the table for a while, they can reproduce to a large amount. Okay, they can reproduce to a large number, making it unsafe. Okay, so it's all about having not killing all the bacteria. There's still some of them left, right? Then they will reproduce. Oops. Okay, they will reproduce to a large number after a few hours. And then that makes you sick again. Okay? Hmm. Instead of just saying that the bacteria will multiply, say they reproduce. Hmm. Yes, these questions will come out in could come out in PSLE. All these questions are what we think that no, it might come out in PSLE. It may not be exactly the same, of course, but it could be similar. Okay, and there's no guarantee all this can come out, but we are putting all here so that no, when it really comes out, you are able to do it. Yes, all these are linked to the previous part because they say based on the results of both experiments. Okay, both experiments. So related to this bacteria V here and this whole parts. It's all related, right? This is part C of question 1 only. Part C of this question, which is question 4. Okay, some of you are asking like, won't it be still harmful to eat it if there are some bacteria left? Now, remember, any food you eat in our stomach, it has some acid to kill the bacteria. But if there are too much bacteria that your body cannot handle, then you will fall sick. Okay, or there are some bacteria that your body cannot even kill, then yes, you will fall sick. You get diarrhea, you get fever and all, you get nausea, and everything. Okay, you might vomit and all. But I will not say for sure if you eat raw food, you may get sick. That's not true. But uh, there is still a good chance to fall sick, right? Because if your body is not used to eating raw food, then you might fall sick eating it. Okay, because people eat sashimi, right? Sashimi is actually raw salmon. Okay. Okay, Kate, let me see your question. Let me trying to find, uh, sorry, Kate, can you send again? Was it the one on the second point thing? Will you get marks for the second point? If you don't write a second point, I just saw it. You must have the second point, okay, for that question just now. Is it a P5 or P6 question? This could be a P5 and P6 question. Move up. I want to see the annotation. Okay, let me zoom out later. Tanishka, let me see Tanishka. Sorry, I can't see your question. Can you put it again? Okay, I'm gonna move on. No, bacteria are all microscopic. Can't see them. Hmm. Okay, let me move on. Usually, how many parts are there in the question in PSLE? How many parts are there in the question in PSLE? If it's one question, if it's 1 mark, is could be just one part. If it's 2 marks, could be two parts. Even 2 marks could be one part. That could be they could be asking you to state and then explain, talking about the same thing. Okay, so it's hard to say. Sometimes one part, sometimes two parts, or even more. Okay. Okay, question 5. Okay, now question 5 you have a question on mosquitoes. Now, if you have looked at the PSLE questions in the recent years or in the previous few years, you realize that a lot of times they test on mosquitoes. Okay, so you could test on different kind of mosquito with different characteristic and all. Okay, but this is just mosquito. All right, a lot of questions on mosquitoes. Okay, so if you look at the trend here, I have two graphs, and you can see that they are pretty much similar. Not exactly the same, but you can see that the trend is roughly the same. Like for example, the number of dengue cases from January to May is an increase. This is an increase, right? From here to here is an increase. Then from May to June is a decrease. And it's the same for amount of rainfall. From Jan to around April, May, in between, it increases. Okay, it may not be exactly the same, but the trend is there and they are very similar. Okay, so in this case, now based on the graphs, state the relationship between the number of dengue cases and the amount of rainfall from January to April. Okay, and you can see, right? So I've already told you, both of them increases. But what exactly is the relationship? This one, be very careful. Okay, listen to what I'm saying here. Now, when we write relationship, you must have the correct cause and effect. Meaning that the first thing you write, okay, let's say for example, as the whatever variable increases, the other variable increases. So the first variable is the cause, meaning that it results in something else increases or decreases. Okay, so you look at this example. Can I write, okay, let me type this out. Can I write like this? As the number of dengue cases increases, the amount of rainfall increases. Can I write this? I cannot write this because this one don't make sense. All right, if I write this first part here is the cause. Number of dengue cases, this is the cause. And this is the effect. These don't make sense, okay? Please do not copy this down. This is a wrong answer, okay? You can copy this down and write that it's the wrong answer, okay? Do not just copy like this and think that it's correct. This is wrong, If this is correct, right, then we are doomed lah. As the number of dengue cases increases, the amount of rainfall increases. Imagine the number of mosquitoes increases and then starts to rain extremely heavy and non-stop. Okay, so uh yeah, we are cooked. Okay, so it has to be the other way. When there is more rainfall, then there will be more water for the mosquitoes to breed, to lay eggs, to reproduce. Then that results in more of them becoming adult mosquitoes and for spreading the diseases. Okay. Yes, there's a screen being shared. Maybe I think you might be a bit lagging, so you might want to rejoin again. All right. So the correct way to write this and the complete one. Now, right. So I can phrase it in this way. This is the correct one. Okay. Let me put this in red so that it's clear. This is the correct one. So the greater the amount of rainfall, the greater the number of dengue cases. Or you can say as the amount of rainfall increases, the number of dengue cases increases. So what I'm stating here, this is the second template using the greater and the greater. But of course, you can still use the first one, which is as the amount of rainfall increases, the number of dengue cases increases. You can definitely use that, okay? So in this case, the cause is the rainfall. This is cause, and it results in more dengue cases, okay? So effects. All right, so you must get this correct. Yeah, correct. 子谦, that is correct. I mean, what you say makes sense. What you say is correct, that it doesn't make sense. Okay, yes. Why do you have to use relationship method? They are asking for relationship. What do you mean? Okay, let me change the color here. Some of you are saying that, okay, red maybe is wrong one. Okay, so this is the correct one. Correct one, I put it as green. Okay, wrong one, I put it as red. Okay, so some of you, yes, red one as the wrong one. So green is the correct one. Green light. Okay, so let's explain. So what's the relationship here? Why when there's more rainfall, there will be more dengue cases? Actually, just now I already said out the answer. All right, when there's more rainfall, now you know mosquitoes like water. Okay, that's when they have plenty of stagnant water. After the rain, there'll be puddles here, puddles there. All right, pond here, pond there. And then there'll be a lot of stagnant water for the mosquito to lay their eggs. Okay, so that should be the first thing you relate. So you must understand the life cycle of mosquitoes and all this. Okay, so this is the first part. First part of your answer. With more rainfall, there was uh there will be more stagnant water for mosquitoes to lay more eggs, to lay eggs. Lay more eggs is fine. Okay, there will be more stagnant water for mosquitoes to lay eggs. Okay, so that means that they will lay more eggs. And this is only one mark. This is only the first mark. How does that lead to the number of dengue cases increasing? Okay, so after you tell me they reproduce more, they lay more eggs, or whichever, they breed more. Okay, then the second part is telling me that all these eggs and young eventually become adult mosquitoes that will spread the dengue fever. Okay, so that is the second mark. Stagnant means the water is not flowing. That's stagnant. Because the mosquito will not lay eggs in water which are flowing, like river, right? If it's a river, the water keeps flowing, then their eggs all fly, all get washed away. So there's not, and the eggs cannot develop lah. Okay, so they will usually lay their eggs in water where the water is not moving, stagnant. It stays there, like a puddle of water. Okay. What if we step on the mosquito eggs? I don't even think that you will find the mosquito eggs. By the time you see them, they are really like wigglers wiggling around. Okay, of course, if you spot them, you're not likely to spot them when you step on them, lah. Okay. That depends. So, one of you is saying that the water will evaporate after some time, so none of the mosquitoes survive. How do you think we have mosquito nowadays? There must still be some stagnant water for the mosquitoes to breed, right? Okay, sometimes a big puddle of water, and if the big puddle of water, it takes a long time to evaporate. Evaporation can be very slow. All right, evaporation can be very slow. So the mosquito eggs don't need a long time to hatch. Okay. Okay, I think some of you are asking if you don't write the word stagnant, is it okay? I think it's fine. Okay, we don't have to be so specific. So you just say that you definitely must mention water because the mosquito lay eggs in water. Okay, so mention the water. Stagnant is okay if you don't write it. Because stagnant is more specific for those who truly understand, like know about what mosquito laying is in the water that don't flow. But I think water itself is fine. So if you just write there will be more water for mosquito to lay eggs in, that's fine. Yeah, no need to be very specific on that. Do not need to specify Aedes. I know Aedes is the one that causes dengue fever, but I think even if you don't write Aedes, it's okay. Your teacher said not to use the results. So do I still have to write the exact temperature? You're talking about the relationship, is it? Yes, you have to write the exact temperature. Tanishka, I think this part, right? You're talking about this part here. Yes, you must have the exact temperature, 25 to 35, 35 to 45. Tanishka, why? If, okay, sorry for those, I just need to answer this student's question. Now, you see, if I don't include the temperature here, it doesn't make sense in my answer. You think about it. If I just write it in this way, as temperature increases, number of bacteria increases. Then I write as temperature increases, number of bacteria decreases. Then I do not know when that happens. Okay? So I need to be very specific, at least on the temperature. Okay? Hmm. No, Gabriel, I think it's fine if it's just water. Okay, if just water, it's okay. But yes, technically, they lay eggs in stagnant water. But I don't think that is the main requirement for this answer. Yeah. Is it possible to find mosquito eggs? Possible? Possible? No, no. Break. Let me see. Okay, it's 8:30. Maybe we have a short break. Let's say 3 minutes. Have a quick toilet break. Right. Then we'll come back at 8:34. 8:34. Yeah. Okay. So come back at 8:34. Thank you. Anushka, stagnant water. Mosquito eggs find in stagnant water. Stagnant water can be found, let's say, for example, under a pot of plant. Okay, because sometimes the pot of plant, when too much water has been added to the pot of the soil, then the water drains out and stagnant there. Yeah. Or what you always see in the advertisement by the NIE, right? NEA, right? On the television, if you saw some of those when they want to prevent the breeding of mosquito, some of those rooftop lah. Usually is the flower pots, the base of the flower pot, or in a pail of water, right? If you have a pail of water that is put there for too long, then the mosquito might start breeding there. No, I'm going to move on to fat test already. Next one is fat test. Question 4B, sorry. 4B, I'm not done. 4B, maybe it's 4B here. This one. 4B is this one. Hmm. Yes, bucket of water can be considered stagnant water. It can be. But the thing about stagnant water that the mosquito breed in, right? Less likely to be a bucket of water that just come out from the tap. Usually those stagnant water that they will breed in are those water that contains quite a bit of bacteria because the wigglers, the larva of the mosquito, they need food, right? And their food is basically the bacteria, the microorganism in the water. So if it's just water from the tap water, uh, they are unlikely to breed there unless the water has been there for a while. Then there will be a lot of bacteria inside, and then the mosquito will breed there. Okay, maybe. For the previous question, do we need to specify the temperature of the shellfish decreases after leaving on the which part do you not want to specify? Because you kind of like mentioned the whole thing. Do you need to specify the temperature of the shellfish decreases? Oh, decreases after. Or do you need to specify that it decreases because it was cooked in boiling water? I don't think that is necessary to specify it will decrease to room temperature. But if you have added that, I think it's fine. Maybe even better. Okay, but I don't think it's one of the mark allocated to it. Yeah. Yes, they only need a small puddle. Okay. Is everyone back? It's already 35. Okay, I got distracted. Okay, we're gonna move on to fair test. Okay, we're gonna move on to fair test. Wow, spoke so much for relationship. Okay, fair test. Now there's just now one of you already mentioned. Fair test is when there's only one changed variable. Yes, one changed variable. Okay, so for only one for fair test, all the other variables should be kept the same. Right? There's only one variable that you intentionally change for the experiment. If you change more than one, then your experiment is not fair and you cannot really determine anything. Okay? Now let's say for example, okay, I use the very standard one, rate of evaporation, right? If let's say I have two buckets of water, or rather, okay, maybe more scientific, I have two beakers of water. No, I cannot use two beakers. Okay, just go back with bucket. If I use two buckets of water, but one bucket of water is hotter, has a higher temperature. Another bucket of water, the water has a lower temperature, but my bucket is smaller. Then I have two change variable. I have different in temperature, I have different sized bucket, which changes the exposed surface area. I think those who are in P5 and above, you know this. Okay, so if I change the bucket size, which changes the exposed surface area, and I also change the temperature, then I will not be able to tell which variable is the one that affects my results. Then it's not a fair test. That's what we mean by fair test. If it's a fair test, you can only have one change variable, and that one change variable will tell you uh when you get a result, that result must only be because of this one change variable. If I have two change variable, then I will not know which one causes that, which variable caused that result. Okay? Right. So there are a few ways they ask about fair test. There are a few ways they ask about fair test. So the very simple one are those they ask you, okay, which other variables that you must keep constant? This is just testing you to identify other variables that affect a result and you must keep constant. So when they ask for other variables, you must mention variables that are important variables. You cannot just give random variables that have no effect to the experiment. Important variables that affect the results. Okay? So although we say that all other variables should be kept the same, but there will be some variables that don't really make sense and don't affect the result at all. Has no effect to anything. Like for example, I have two pots of plant. I have two pots of plant and I want to see like maybe number of leaves, I want to find out how the number of leaves affect the rate of photosynthesis. So you cannot be writing variables like, oh, keep the color of the pot the same. That I would say is a wrong answer. Although technically we say all other variables should be kept the same, the color of the pot should be the same. But if you really change the color of the pot, it really has no effect on your results. Then that is a variable that don't make sense. So you have to write something important, like for example, amount of water added to the plant. Okay, location of your pot of plant. Those are the ones that will really affect your experiment. Okay, not color of pot, not the color of the car, whatever that is. Okay, so color, it depends on the question. Okay, most of the time the color, all these are not the important variables. Okay, one of you is asking, since we only have one variable that is changed, what about measured variable? Measured variable is your result. So of course, that is something that you get out of the experiment. So you don't say that you keep that constant or what. Okay? But when you prepare to do the experiment, all these variables you are keeping the same. Okay? Let's say for example, evaporation of water again. I will not say that I can keep the amount of water left the same because that is the result. So technically, yes, okay, that is also something that I cannot keep the same. But it's not something that I intentionally change. Okay? All right. So in the other ways that they ask the question, state what Gary should do to ensure a fair test. Okay. So this is what you need to take note of. What should he do to ensure a fair test? Okay. Change what variables, keep what variables constant, things like that. Okay, to ensure a fair test. Identify a setup. Okay, this one is the easier one also. Identify which one he should use to ensure a fair test. So you must choose only one change variable. The rest keep the same. Okay. Now, explain how using equal volumes of liquids A and B enables Gary to carry out a fair test. So this is the constant variable. And this is the one that we are focusing here this time. Okay. We want to we want to be able to answer such question because it's a very common question. They ask you why you want to keep this variable the same. Okay, why using equal volume to ensure a fair test? Okay, so we want to use these templates. Okay, so you'll come to that. Now another one, explain why Gary used the same type of container for his experiment. So again, the type of container is the constant variable. So this one also use these templates. Okay. So like I said, when we state the constant variable, only write those that are critical to the experiment, not just any random variable. Okay, they must be critical to the experiment. All right. Now, so if you are asked such question, why do they keep this the same, keep that the same in your fair test? So you have to phrase it in this way. This is the template that we would like to share with you all. So it ensures that the constant variable does not affect the measured variable. Okay, so this constant variable, let's say for example, okay, I use the last one, explain why Gary used the same type of container. So it ensures that the type of container does not affect whatever the experiment result is. So does not affect let's say for example, the amount of water left. Okay, keep using the same example. Amount of water left after an hour, after 1 hour. Okay? Let's say for example, okay, rate of evaporation. So this is the easiest way, the shorter, some of you keep asking for shorter answer. So this is how you can keep your fair test answer short. It ensures that the type of container or the constant variable does not affect the amount of water left after 1 hour. Okay? But if you prefer to write a second one, which I think some schools will recommend, which I don't think is necessary, right? Because you just need to, what is different here is, okay, we mentioned that what the change variable is. Okay? The only difference between the two answers is that the second answer tells you what the change variable is. Okay, so it ensures that any changes to the amount of water left is only affected by whatever is the change variable and not the type of container. This is okay, of course, this is okay. But the first one is shorter and concise, answering to the question. Okay? Right, so follow these templates. Right. So let's look at this question and let's try to, answer some of these questions. Some of them are relationship as well. So look at that. Now we have this question, and you can see this on reflection of the light. The light from the torch reached the material X, then is reflected and recorded by the light sensor. Now, what is the changed variable? What is the change variable? From the question here, you can see, right, he placed the torch at different distances away from X. From the graph, distance of X from the torch. Okay, so these are the changed variable. The same thing, they are the same thing. Okay, then what is being measured? Amount of light that was reflected off. Okay, what is measured? You can say what is measured is the amount of light detected. This is the measured variable. Amount of light detected, which is the same as amount of light that was reflected. Okay, very similar, very similar. Okay, so either one of these can be the measured variable. But I would say the better one is just what is from the graph itself. Okay, so amount of light detected by the light sensor. Okay, so describe how the amount of light detected is affected by the distance of material X from the graph. So you see, describe how, right? Describe how means that it's a relationship. This is relationship. Amount of light detected, this is measured variable. Distance, this is the this is the changed variable. Okay, so you follow the relationship templates. You can use either one as something increases, something, or you can say the greater the distance, lower or the less the amount of light detected by the light sensor. Okay, so you must use all those comparative terms. So my answer in here for this question is in terms of S, using the first template. As the distance of material X from the torch increases, the amount of light detected by the light sensor decreases. Okay, so the easiest way to do relationship question is really to just follow the phrasing used in the question. Amount of light detected, that's the measured variable. Distance of material X from the torch, that is the change variable. There's no need to go and change all this. Just write exactly what is given, if it's given. Okay? Don't try to write it in your own words and everything get wrong. All right. How many constant variable must there be? Basically, everything else should be a constant variable, except the measure and control, except the measure and change variable. Okay? Okay, next part. Okay, so this is relationship. This one we went through how to write relationship just now already. Okay, we spent 1 hour on those. Now, next part here. Explain why Jin Kang conducted his experiment in a dark room. Now, this question seems like a fair test question. Okay, you can say this is a fair test question or partially a fair test question. Okay, because this experiment involves light, and we usually want to do light experiment in the dark, so that whatever is detected by the light sensor is not from other light source, like the light from your living room, the light from whichever. So it can only be light from the torch. Okay, so that is why it conducts in the dark room. You want to ensure, again, you can use similar phrasing as how you do a fair test. But it's not exactly like a fair test. It is like partially like a fair test. So it ensures that the amount of light detected, okay, only comes from the light source. Okay, the light source, the torch itself. Okay, and not any other light source. So that kind of still keep the experiment fair, so that we don't change other things. We only want to change we only want to change in this case the distance. Okay, so your results must be accurate, right? We try to keep to only one light source. So I wouldn't say this is actually a full fair test kind of question, okay? But this can be a quite a common question. Okay, so take note, this can be quite a common question whenever we are dealing with the topic of light. Or rather, whenever any experiment is done involving light. So they would usually want to do in the dark. Okay? Yeah, I think maybe the answer is fine. So I think it's about just identifying that okay, there will only be one light source, which is the torch in the experiment, and no other light source. That is sufficient. Okay? Yeah, I think one of the answer, I think that is good. So that one you phrase it in terms of fair test, like Jia Tao I still answer to ensure that the light from the surroundings will not affect the amount of light detected by the light sensor. Okay, I think that is a good answer. Yes. So there can be a lot of ways to phrase this. Yeah, I think the real answer is fine, just a bit long. I would say this is more for accuracy. More for accuracy. Yeah, not reliability. Reliability is when you do an experiment results, you do it multiple times and your results are all consistent. So that tells you your results are reliable because you have done it multiple times and they are agreeable with one another. So that's a reliable result. Accurate result is when you do an experiment, what you get is really the true value that you want, with no other light source affecting your results. So that's accuracy. So this is less of a fair test, but close, kind of linked to a fair test, but not really a fair test. Okay, so related, but not fair test. Oh, is okay. I give you another example, right? In the PSLE, they actually test on recording sound. You know sound, right? Uh, so they have this sound sensor, just like a light sensor. So they detect sound from the experiment. And that sound was water dripping onto a surface. So when water dripped on the surface, they recorded a certain value. Okay. But when there was no sound, when the water did not drip, there was some sound detected. So it is a very similar question, but now this is in terms of light, that is in terms of sound. And you all know, right, when you don't purposely produce any sound from any devices or what, there's actually some background sound. Okay, noises, you can say they are noises. Right? For example, when you sleep, everything is quiet, but somehow, sometimes when you cannot sleep, while you hear a lot of things happening in your ears. Those are the background sound. And that can be detected by a sound sensor. Okay? Yeah, still water is fine, Tiffany. Question six. This is question six, right? Thomas, you mean the part A? Yeah, 9:30. We end at 9:30. Okay, so I need to speed up a little bit, just now I speak too long for relationship. Okay, Thomas, done? Okay, come back to part B, Can I zoom out and see if I can see both? No? Okay, I can shift this answer down a bit. Yeah, I think Taylor, your answer is fine. No, if I put the two-page view, it'll be too small. But now you can see answer for A and B, right? Okay, they are both in green. Huh? Tanvi, what do you mean? The question is not related to what we are learning now. What do you mean? We are learning relationship, fair test, all this what? What are you talking about? Okay, I'm gonna move on. Okay, see So in another experiment, Jin Kang wanted to find out which materials A, B, or C reflect the most light. Okay, now we have another experiment. State one variable that he must keep the same in this experiment. What should he keep the same? This is the new aim, right? To find out which material reflects the most light. This is the new aim for the new experiment. Okay, so what must he keep the same? Okay, so basically, whatever is in this experiment that was changed, right? This change variable must now be kept the same. If I want to do a different experiment and my new change variable is the material, this is the new change variable. Okay, then I must keep the distance the same. Okay, so that is the answer. Now, for distance wise, you can either say distance from the torch to the material, or you can say distance from the material to the light sensor. Okay, either one. Because you change one is changing the other. Right? Yeah, you made the OCV the same, right? So it was the distance, so keep that the same now. Especially when we are dealing with question on light, right? So it's always affected by distance. The further they are, the light intensity changes. So you want to keep that the same. Okay, of course we can have different answer. I see some of you hold on thickness of the materials. I think that's fine. The only thing that we want to change is the material, the type of material. So yes, thickness is fine. Yeah. Although technically the thickness don't affect the amount of light reflected lah. Okay, but I think that can still be accepted. Brightness of the torch. Uh, I think okay. The initial brightness lah. The light produced by the torch. Yeah. But the most instinctive, I would say, is the distance because in the previous experiment, we are changing the distance. So in a new experiment, my new aim, I don't need the distance to be changed. So I keep the distance the same. Okay. When object is near to the light source, the amount of light detected increases. Yes, Thomas. Keep the light intensity constant. How do you do that? So I'll actually be more specific on that. So maybe the distance is the one that affect the light intensity, or maybe the type of bulb, the type of torch. Yeah. So how do you keep the light intensity constant? I mean that is what you want to achieve, but when you do the experiment, how are you keeping it the same? Okay. The distance of the light source. Go. What do you mean distance of the light source? Distance is between two things, right? What? Between distance of light source to what? You must be specific on that. Okay, I'm going to move on. Question 7. Okay, what we have here? Okay, this one we have a container. We have this setup with container X, container Y. Container X only has sugar water, container Y has sugar water and substance N. Okay, so, oh, this is a maybes. Now, conducted an experiment to find out the effect of substance N on butterflies with two containers X and Y, blah, blah, blah. Okay, so you want to find out the effects of substance N on butterflies. Okay, so this is the aim. So what are we changing? Already in the diagram, you can see, right, it's either with or without substance N. Okay, then what are we measuring? Right, from the results, you can see, right? Okay, they say that she counted the number of times butterflies visited each container for a duration of 2 hours in day 1, 3, and 5. Okay, so this is the measured variable. So we are changing the presence of substance N in the containers. Okay, we are measuring number of butterflies, number of times butterflies visited each of these container. Okay, now part A. This is a fair test question. Okay, this is a difficult, I would say it's a difficult fair test question. Suggest how the arrangement of containers in the cage allowed for a fair test. Actually, a similar question came out for PSLE. I can't remember which year, but very similar, quite similar. On the first look, you may not think that this is a fair test question, but this is a fair test question. What are they talking about? Arrangement of containers allowed for a fair test. I mean, they specify as a fair test, but just now when we talk about fair test, there must be something that is being kept the same, right? Okay, when we talk about fair test, there's a certain thing that is being kept the same. Same volume of water, same type of container. So what is being kept the same here that it ensures a fair test? So you have to identify what is being kept the same when they are arranged like this. No, we are talking about arrangement, not the amount of sugar, water. We are talking about the arrangement of the container. It must be related to this. So if we arrange them like this, what is the thing that is kept constant? Yes, what is kept the same? What is kept the same? I would say this is a difficult one. Okay. Thank you, Tanisha. Distance between the entrance and the container, very good. Right. You just imagine, right? Okay, let's say you walk into a room, you have your friend one, friend two. They are both your best friend. Now, which one will you walk to first? It must be fair, right? Okay, which one I want to walk to? I want to walk to friend one, I want to walk to friend two. And to be fair, okay, you come in from right in the center. Alright, so we are keeping the distance the same. The distance between the entrance, the entry point, and the containers. Okay? Don't don't walk. Okay, alright. So you mentioned that what you are keeping the same. So we are keeping the containers the same, or we are keeping the distance to the containers the same. So the containers will place an equal distance from the opening. That is your first mark. Okay, your first mark. So you identify what is being kept the same, then talk about how this ensures a fair test. Okay, so this is the constant variable distance. Then second part, explain. So what does it do? Okay, so how does it ensure a fair test? So it ensures that the distance does not affect the number of times. Okay, so basically use the template. This part here is the template. This is the template. But you must identify correctly lah. Okay, the distance between the containers and the opening, that is the change. This is the constant variable that we've identified. Does not affect. Okay, this is the measured variable. So this part here follow the templates. All right. walk in the middle. But you must walk to something lah. Otherwise, experiment fail. Alright. The butterflies will have to go to one first. Charlotte, to answer your question, when there is a false question, can you use energy to help answer? It is possible. Okay. In a in a recent PSLE paper, there was a question. Part A was on energy, part B was on forces. Yeah, so they can have forces energy in different parts of the same question. Okay, but if that question part itself asks you for energy, then you cannot be answering in terms of force. Okay, I hope that answered your question. Audrey, don't worry. Okay, we will try to finish. If really cannot finish, we will do it next week. Okay, but not to worry. We should be able to finish. All right. Okay, I'm going to move on. Anyway, if any of these you have not copied finish, all right, you can quick once the video is up, you all can take a very quick look because you can just toggle to where you need to copy a correction, right? Okay, so if at the end of 9:30 there are some things that you have not copied finish and all, just quickly revisit the video and copy when you need to, okay, or revisit my explanation and my annotations, okay? It's not like you have to watch the entire first part, right? So you can just quickly toggle to where you need, right? So that makes it easy. Okay, next part. The number of times butterflies visited both containers on day 1, 3, 5 are shown. Okay, so we want to find out, we want to describe how substance N affected the number of times butterflies visited both containers. Okay, let me zoom out so that some we are still copying. Okay, all right. So again, it's a describe how. So again, it's relationship. Now, for this, you have to analyze the question. Analyze the graph, I mean. Okay. Container X is the white bar graph. White bar graph here, X has no substance N. So you can see, right, for X, initial is here, it has decreased over time. And X has no X, no N. Has N. Okay, just put it here so I don't get confused. Okay. So how do I explain it? You see 2 marks and it's a relationship. So I must mention for each of these container. Okay, how is affecting the number of butterflies going to X, butterflies going to Y. Okay, so without substance N, you can see, right, over time, right, it has decreased. All right, so you can phrase it like this. So you can say without substance N or the absence of substance N in X. Okay, we have to mention the specific container, right? Because otherwise, of course, they won't know what you're talking about. So you have to mention without N or the substance of N in container X. You must mention this. Right, that caused the number of butterflies that visited to decrease. Okay, this is the trend. It has decreased. But for container Y, it has substance N. And you can see, right, how did it change? If it has substance N, it has increased. Okay, it went up. It has increased. Okay, so instead of the absence, you can write the presence. So these are just my way of presenting it. Of course, you can write it in your own words. Like for example, just stating that container Y having substance N caused the number of butterflies visiting it to increase. Okay, so as long as you tell me that there is substance N in container Y, and that caused the number of butterflies to increase, that visiting to increase. Okay, so I've highlighted like the main thing that you must really write. Jayla, I'm just looking at your answer for question 8A, the next one, after going through the notes part. Your answer is actually okay, but I would suggest to, instead of the 20 grams, 20 to 14 grams, you put it as 36 to 14. So start from the part where it decreases, okay, which is from R, from 36 to 14. Then when fertilizer was added from 10 to 20. Okay. CV, did I write constant variable? CV is change variable. Did I write as constant variable? Clear? Okay, but if I have written wrongly, I've clarified that CV is for changed variable. I don't think I wrote for constant variable. If I did, then I apologize for that. It should be for changed variable. Okay, give you another 10 seconds. Okay, are you done? Okay. Do you have to write both? Yes, write both. Because the because writing one does not mean the other, Albert. What I mean by that is that if I just write, let's say for n in container X, so without n, number of butterflies that visit the X decreases. But I cannot say for sure that if I have n, it has increased. So I need to write for both containers because the trends are not the same. Okay? And I cannot assume that it will increase if the other one decrease. Right? I may have I may have used n and it has decreased even more. Who knows? Right? So you need to state for both. Okay? Right. We're gonna move on. Okay, next part, last part, conclusion. Okay, conclusion to conclude today's session. Right, so conclusion, very important. You must remember that conclusion is used to answer the aim of the question, of the experiment. Okay, like for example, I do this experiment to find out how something affects something. Okay, I want to find out if temperature affects the rate of evaporation of water. So after I do all my experiment, or I got my results, I can conclude, yes, okay, temperature affects the rate of evaporation of water, or I can conclude a relationship. The higher the temperature, the higher the rate of evaporation of water. That is this. That is this one. Okay, so conclusion can be written in the form of relationship. I can also write conclusion in the form of comparison. Okay, let's say for example, I just compare their conductivity, the thermal conductivity. Okay, whether material A is the better conductor, material B or C is the better conductor or best conductor. Okay, so it can be comparison depending on what your experiment is about. What are you doing your experiment for? Okay, so conclusion must answer the aim. If they tell you the aim is to do what, then your conclusion must be answering your aim. Let's say for example, right? Uh, to find out, okay, coming back to question 7, to find out the effects of substance N on butterflies. So actually my conclusion could be that substance N causes more butterfly to be attracted. That's it. That could be my possible conclusion relating to this aim. I must answer the aim, right? How does it affect the butterfly? Okay, so having substance N, it attracts more butterflies to visit the flower. Okay, but depends on my results. Okay, so basically what my point is that the conclusion must answer the aim. Okay, now it could just be a statement. This is for those that are the experiment is a bit more simple. Like for example, okay, germinating seeds produce carbon dioxide. It's just a statement. So the aim could be that to find out whether germinating seeds produce carbon dioxide. So yes, it produces carbon dioxide. That's it. Okay, that could be my conclusion. All right, so let's try this question. Again, we are practicing a lot on relationship and fair test, okay, because those are very important and very frequently asked experiment-based questions. Okay, so let's look at this. This is again a relationship, and some of you were already giving me your answers. Okay, so relationship, write it down. And if you have listened carefully since the earlier questions, right, then this is nothing new. All right, as you can see, from here to here, it has increased. From here to here, it has decreased as we increase the number of fertilizers. Okay, so like I said, be specific. As the amount of fertilizer increased from 0 to 10, okay, it has increased. As the amount of fertilizer increased from 10 to 20, it has decreased. Okay, so state down the values. All right, so I will not go through so much on for this because we have already went through all the relationship questions earlier. Okay, so let me just put the answer here for your reference. So like I said, state them clearly, especially the change variable. Okay, the change variable will be the one that is most crucial, 10 to 0 to 10 grams, 10 to 20 grams. This one must definitely write because it will show where your trend ends. Okay, if you don't specify that, then cannot tell. And also, like I said, right, if we have two trends, try to use the template that starts with as the what increase, then what happens? Okay, because in this way you can state the specific values. Yes, Gabriel, your answer is the same as mine. Thank you. Yes, again, you have to write both because these are two trends in the same experiment. So you have to write both, yes. Kids, there are some keywords that you cannot miss out. So I would say, uh, from what they say is that as long as the students show understanding in their answers, okay, they most of the time they can get the marks. But there are some keywords that you cannot really miss out. Like for example, words like evaporate, right? Water evaporate to become water vapor. Now you cannot miss out the word evaporate, right? So some of these keywords you must write in order to get a mark. Okay. But generally, if it's an explanation question, then if the examiner see that you can understand, you have the correct phrasing and all, even without the exact keyword, okay, you may still get the mark. But we will still recommend you to use as much scientific keywords as much as possible, okay, because that will make your answers easier to write. Because if you try to phrase it in your own answers, then you may not catch the point. Will the annotations be on the Google slide? Now, there's no Google slide here. You will be on the YouTube video recording. Okay, so there's no Google slide. It's a recording of this session. Yeah, so all this will be there. Okay, I'm going to move on. Now, two variables that he must keep the same in this experiment. So this on fertilizers, and what we are measuring is the mass gain of plants. So what should we keep the same? What should I keep the same? There can be a lot of answers, okay? There can be a lot of answers, but definitely not the color of pot. type of plant? Um, yes. Okay, now we try to write variables which have not been mentioned in the question. We try to write variables that have not been mentioned in the question. So right, type of plant maybe I would say not the best answer. I would not recommend that because question has mentioned they use identical plants. Okay. So what else have they kept the same? Identical plants filled with garden soil. So these are the things that they have mentioned. Okay. Fertilizers. Okay, you may mention that use the same type of fertilizers, but we are changing the amount, right? Okay, type of fertilizers can, but type of plant they say is identical, so I would say not a good answer. Type of soil they are using garden soil, clearly mentioned, so we will not say it's the best answer. So what I will recommend you to write is in terms of because we are involving plants, right? So we should water the plant with the same amount of water. And where should we put the pot of plant? All these plants, they should be placed in the same location. Of course, if you are more specific on the location, you can say temperature of the surrounding, amount of light given to the plant. Yes, all these can. Size of the pots, I think that's okay. Amount of leaves, they are identical plants, so amount of leaves are assumed to be identical. So I wouldn't say that's the best. That's a good answer. I will not say the amount of leaves because they are identical plants. Identical means everything else kept the same. The length of the roots, number of leaves, they are all kept the same, assuming possible. Okay? So anything related to the plant itself, the parts of the plant, they are all kept the same. So I will not accept those answers. Type of fertilizers can. Yes. Keyword increase. Increase can you can say increase is the keyword. Yeah, definitely. Thickness of stem, no, nothing relating to the thickness because they are identical. Temperature of surroundings, yes. Age of plant, again, nothing related to the plant. Okay, water they receive, yes. Location, yes. Yeah. Okay, possible conclusion for this experiment. What is a possible conclusion? So what are we finding? What is the aim? Okay, I haven't identified the aim, right? To find out how the amount of fertilizers affect the plant growth. Now, a possible conclusion, there are a few things that we can conclude. Okay, so a conclusion can be a statement. And I want to find out how the amount of fertilizers affects the plant growth. So does it mean that we will rewrite the relationship? It is possible, but when it's a conclusion, we don't need to be so specific. So you could give me again a relationship, but a general one. Other conclusion could be that you can identify how much fertilizer is the best. Okay, because again, how the amount of fertilizers affects the plant growth. So anything related to the amount, such as using 10 grams, and then the plant will grow the best. That still answer the aim of the experiment. Okay, so if you tell me that you grew the fastest or the plant growth is the best when you use 10 grams, that's good. Yes, the plant grows best with 10 grams of fertilizer. Very good. Yes, I see some of you writing this answer, so correct. Good. Okay, so this is a possible conclusion, right? So identify which is the best, be the best amount for the plant growth, or in other type of question could be like best conductor of heat or what. Okay, okay, these answers are shorter, so we will move on very quickly soon. Give you another 10 seconds. Like I said again, if let's say you miss out on any of the annotations or any explanation that I had mentioned, but maybe you went to the toilet or you missed out, you can always revisit the video that will be uploaded quite soon. Maybe you can find it tomorrow, maybe 2 days later. Okay, so do wait for the video to be uploaded. Okay, now let's move on. Okay, last question. Last question for today. Yes, so we can finish it. Right. Now, so this question, one look at this, I have electric heater, I have thermometer, you know that this is relating to heat. Okay, remember last week I've taught of you how to use the triple C, right? Use triple C. First thing you look at the command word. First one, explain. Okay, that's a command word. We need to first do explanation for the first one. Concept. You look at the diagram, you know this is heat. Okay? And what's the context? So let's read the question in greater detail. I have two identical beaker, equal volumes of water. Okay. Now X is wrapping around beaker A. Beaker B, we have material Y. That's basically the main thing. Same distance, okay, keeping a lot of things the same. Same water, same amount of water, same beaker, same distance. Okay. Those are the main things. Okay. So you see, right? You see how I've annotated this. I only highlighted or I only underline and circle some of these important phrases that can help me in my answer. I've identified what have been kept constant and what are the main things that are different between these two setups. One is wrapped with X, one is wrapped with Y. Distance is kept the same. Okay. Then our graph, as time passes, okay, you can see temperature has changed for different beakers. Now, part A, explain how the position of the thermometers resulted in Zen obtaining accurate results. This is not a fair test question. This is on accuracy. So how were the thermometers positioned? What is the correct scientific way to place the thermometer? Okay, so this is correct, right? Both are the same. They are correct. They should not be touching the sides or the base of the beaker. They should not be in the air. They should be the bulk of the thermometer must be submerged in the water, in the liquid, whatever that is, water in this case. Okay, and not touching the side of the beaker. Okay, so that is to ensure an accurate result. Because if you put it if you touch the sides, then you are measuring the temperature of the beaker. Okay, so this is one of the answer. One possible answer. They are not in contact with the beakers. Okay, so we are only measuring the temperature of water, not measuring the temperature of the beaker. Yes, Theodore, you are right. But you must explain. You cannot just tell me, oh, they should be like this, like this. The explanation is that, okay, we are measuring the temperature of water, not not the beaker itself. Okay, just give me 5 more minutes to finish out the next part, and then I think we are done. Okay, and so again, this is not a fair test question. So do not use the fair test template at all. We are talking about experiments accuracy. These are experiment techniques. So when you do the experiment, how should you do your setup? How should you place your thermometer? How should you read your thermometer? All this you must also know. Okay? And all right. Now I'm gonna move on to the next one. Last part already. So based on your results, state what Zen could conclude about materials X and Y. Explain. Okay? So command word here, state, explain. Now, so you see state and explain, that means that I can use AIR. For those who attended last week, answer, information, reasoning. Answer. So what is my conclusion? That's the answer. Okay, we answer straight away. So the first thing here, the conclusion must be this, right? They ask about the materials. Okay, so this question is on heat conductivity. So if beaker A temperature is increasing faster, so it must be a better conductor. A must be a better conductor. It gains heat faster. So we can conclude it is a better conductor. Information, I for information. So from the graph, what did I tell you? The temperature increases faster than the water in B. Temperature of water in A increase faster than water in B. So this is what you obtain from the graph. Then finally you connect the both. Okay, so how does temperature increasing faster leads to better conductor? Okay, so the reasoning here is to connect this part here about how fast they gain heat. Okay, how fast they gain heat. So X gain heat faster than Y. Okay, that shows that it's a better conductor. So that is your reason, your explanation. So I repeat again, A is just answering the question. It could just be an X or Y, but in this case, they ask for a conclusion. So then they ask you, how do you explain you get this? How do you get this conclusion? Then, of course, you must extract data from the graph, from the table. Okay, so from the graph, we see that the water in A increased temperature faster. That must mean that material X gain heat faster. Okay? Wesley, your answer can be better, right? By mentioning the temperature of water increase faster. So gain heat faster and causing temperature of water to increase faster. So that is the information from the graph. Yes, if you are done with this answer, you have copied finished, then yes, we have come to the end of this webinar. Right, and remember next week you have the last segment. Okay, we will finish up on control setup and some of the standard answer template for the different topics. Okay, so if you're done with this, yes, you may go ahead and leave the webinar and have a good rest. Okay, and know you have a long day. Thanks so much for joining me today, and I hope to see you next week. Okay, all right. So yeah, once you are done copying, you may leave already. Thanks so much. So I'll see you guys next Thursday night, same time. Okay, I just put it here for another minute for those who are still copying. Uh, yes, just one of you said you have a thank you, Rusra, and Ziqian and Taylor and all. Thank you. One of you want to ask a question. Yi what's your question? Yi, you have a question? Are you still here, Yi? What's your question? Is it you want to speak? Oh, does magnetic field of the Earth affect humans or matter? Huh? Does the magnetic field of the Earth affect humans or the matter? I would not say it affects human. What matter? What matter are you talking about? It affects maybe magnetic materials, the compass and all. Yeah, if that's what you're talking about. But it doesn't really kind of affect us in a way. Okay? Yes. All right, so if there are no other burning question, right, then that's all for today's session. Yes. Thanks so much, and I hope to see you all next week. Good night.